Chinese remainder theorem. Let us discuss about what is the Chinese remainder theorem and how it is used to solve the unknown number. Chinese remainder theorem states that if m1, m2 and mk are pairwise relatively prime positive integers. So remember all should be relatively prime and should be positive integers. And a1, a2, ak are any integers, then the simultaneous congruences of x congruent to a1 mod m1, x congruent to a2 mod m2, x congruent to ak mod mk have a unique solution. And the solution is unique modulo m, where m can be given as m1, m2, mk. So this is the statement of Chinese remainder theorem. Here the key words are pairwise relatively prime positive integers and simultaneous congruences having the unique modulo. Now, let us take one example problem of that x is congruent to 1 mod 5, x is congruent to 2 mod 6, and x is congruent to 3 mod 7. The meaning is we may that there are n number of soldiers in a troop. If they are standing according to 5 in a row, 1 is pending. If they are standing in 6 in a row, 2 is pending. They are standing 7 in a row, 3 is pending. Or you may hear that there is a vendor who having X number of apples. If he is giving 5 for each, 1 is pending, 6 for each, 2 is pending, 7 for each, 3 is pending. Identify the total number of apples. So this is the one way of using the Chinese remainder theorem for obtaining the solution. So from definition, we know that these are all the A values and these are all the M values. And we have one condition that this M1, M2, M3, that is 5, 6, 7 should be relatively prime to each other. Let us look this 5 and 6. What are the GCD? GCD is what? There is no common divisor. And 6 and 7, there is no common divisor. And also from 5 and 7, both are prime and they are co-prime to each other. We already discussed that two consecutive numbers are always co-prime to each other. In the previous video of co-prime numbers, we discussed that. So now we have clearly understood that for this problem, Chinese remainder theorem is possible to apply because here one clue is if for example instead of this 9, 7, I'm having 9. We cannot apply this because 6 and 9 are not co-prime to each other. So remember that this Chinese remainder theorem is applicable one and only if the m values are co-prime to each other. Now let us continue this solution. For this first what we need to do is we are going to develop one tabular column. I'm going to frame one tabular column by writing what is the value of A1, A2, A3 and what is the value of Z1, Z2, Z3 and what is the value of capital Y1, Y2, Y3. You may have different terminologies, but for all your problems, please follow a common terminology to avoid confusion. And we are going to write capital M first. Now, first let us find what is capital M. Capital M is small m1 into m2 into m3. The values are 5 into 6 into 7. Here the given values are 5 m1, m2, m3. So 5 into 6 into 7 means the value is 210. 5 6 are 30, 30 into 7, 210. Now I am writing is m equal to 210. So this is the first value we are going to fill in this table. The topmost value, fill the m value. Now Now I'm going to go and calculate. I'll write the A values. What are the A values given in the problem are? This is the A1, A2, A3. So I'm going to write that A1 equal to 1, A2 equal to 2, A3 equal to 3. Now the next step is we have to find Z1, Z2, Z3. How to find Z1? Z1 equals capital M divided by small m1. So what are the capital M is? We got 210 divided by what is small m1? 5. So 210 divided by 5 is nothing but 42. Similarly, Z2 equals capital M divided by small m2 which is equal to 210 divided by 6. Here it will give 35. Similarly, Z3 equals capital M divided by small m3, which is equal to 210 divided by 7, which is equal to 30. So now I got Z1 is 42, Z2 is 35, and Z3 is 30. Now we're going to fill the value here. Z1 is 42, Z2 is 35, and Z3 is 30. Our next step is to identify Y1, Y2, Y3. Y1 equals Z1 inverse mod M1. So this is the formula to find Y1. Y1 is nothing but multiplicating inverse of Z1 in modulo M1. So here, what are the Y1? Z1. What are the Z1 we got? We got Z1 is 42. So now Z1 is 42 inverse mod. What is M1? 5. First, bring the value within the residue of 5. So 42 mod 5 is 2. So 42 inverse is congruent to 2 inverse mod 5. Now I have to find inverse of 2 in mod 5. So, and mod 5. So I'm going to take 0, 1, 2, 3, 4. Then 0 to 4. I'm going to find only for 2. Let us find where I got 1. 2 into 0, 0. 2 into 1, 2. 2 twos are 4. 2 threes are 6. 6 exceeds 5. What is 6 mod 5? 1. 2 fours are 8. 8 mod 5 is 3. So from this it is clearly understood that where 1 is produced, when you multiply 2 and 3, it produces residue as 1. So 3 is the inverse of 2. 3 is 2 inverse. So I can write that it's congruent to 3 mod 5. So y1 is 3. Go to the upper table and make that y1 is 3. Now similarly I'm going to find for y2. What is Z2? Z2 is 35. So right. So let us take Z2 is 35. So y2 equal to Z2 inverse mod M2. So Z2 is 35. So 35 inverse mod 6. So bring into residue 35 mod 6 is 5. 6 5s are 30. So 5 inverse mod 6, which is congruent to 5 inverse mod 6. Now find inverse of 5 in mod 6. So I can find mod 6 means 0, 1, 2, 3, 4, 5 until 5. For I want to find the value for 5. So 5 zeros are 0, 5 ones are 5, 5 twos are 10, 10 mod 6, 4, 5 threes are 15, 15 mod 6, 3, 5 fours are 20, 20 mod 6, 2, 5 fives are 25, 25 mod 6, 1. So here obviously 5 inverse is 5 in modulo 5, modulo 6. So here and I can write this 5 mod 6. So I'm filling the table with y2 equals 5. Now I'm going to find for y3. We have Z3 is 30. So find y3 equals Z3 inverse mod M3, which is equals Z3 is 30. We find 30. So 30 inverse mod 7. 30 mod 7 is 2. 3 fours are 28, 7 fours are 28. So remainder is 2, which is equal to 2 inverse mod 7. So under mod 7, the inverse of 2 is 8 because it's obvious that only 2 fours are 8, where 8 mod 7 is 1. So 2 inverse of 2 is 1 in mod 7. The 2 fours are 8. The 2 inverse is 4 here. Okay, 4. So now I'm filling the table is 4 here. So now I got y1, y2, y3 as 3 by 4. Now the final answer is about to obtain. So for obtaining the capital X unknown value, which is congruent to a1 z1 y1 plus a2 y2 z2 plus a3 y3 z3 overall mod capital M. This is the final value. I want to know A1, Z1, Y1. So here we are having A1, Z1, Y1, A2, Z2, Y2. So now make this product in row wise. 1 into 42 into 3. What will you get? 1 into 42 into 3. 1 3 is 3. 3 into 42. We'll have 126. Similarly, 2 into 35 into 10. We'll have 350. Similarly, A3 into Z3 into Y3, 3 into 30 into 4, it is 360. So sum up all these values. Sum it out. What will you get? You will have 836. So, which is equal to 126 plus 350 plus 360 mod. What is the capital value? 210. So, here I can have 836 mod 210. 836 mod 210. When you take 836 mod 210, the remainder is 206. So the final value x is 206. You can check it out. How can we check it out? We have the unknown equations to here. You can apply this. If you put x equal to 206 and I divided by 5, remainder is 1. When I divided by 6, you are getting 2. Divided by modulus on 7, you'll get 3. So this is solved. So we got x equal to 206. So this is how Chinese remainder theorem is used to solve the unknown number.